Good morning, Morgan, and good morning to any of Morgan's friends that are joining us for today's video. And today we're going to be talking about parsers and the different parsers that you're going to use. And really all the parser is a set of rules on how the Python is going to take the HTML input and configure it or organize it, okay? And that has to do with the different styles, if you will, of coding, okay, that you've used. Is it HTML? Did they use the HTML format? Did they use the XML format? Did they use the HTML5? I know it's weird. It's a little confusing, but let's think about all the different brands of cereal there are. Anyway, let's get to it. I'm sure I did a poor job of explaining what a parser is. So let's hear what the machine has to say.
Specifying the parser to use. If you just need to parse some HTML, you can dump the markup into the Beautiful Soup constructor, and it'll probably be fine. Beautiful Soup will pick a parser for you and parse the data. But there are a few additional arguments you can pass into the constructor to change which parser is used. The first argument to the Beautiful Soup constructor is a string or an open file handle, the markup you want parsed. The second argument is how you'd like the markup parsed. If you don't specify anything, you'll get the best HTML parser that's installed. Beautiful Soup ranks LXML's parser as being the best, then HTML5 libs, then Python's built-in parser. You can override this by specifying one of the following. What type of markup you want to parse. Currently supported are HTML, XML, and HTML5. The name of the parser library you want to use. Currently supported options are LXML, HTML5lib, and HTML.parser, Python's built-in HTML parser. The section installing a parser contrasts the supported parsers. If you don't have an appropriate parser installed, Beautiful Soup will ignore your request and pick a different parser. Right now, the only supported XML parser is LXML. If you don't have LXML installed, asking for an XML parser won't give you one, and asking for LXML won't work either. Differences between parsers. Beautiful Soup presents the same interface to a number of different parsers, but each parser is different. Different parsers will create different parse trees from the same document. The biggest differences are between the HTML parsers and the XML parsers. Here's a short document, parsed as HTML.
Alrighty then. So, in this thing, what do we got? We got an A tag, and inside of that it's got a B tag. And according to this the manual, which is used in an older version, it takes that and it wraps that within a body tag, and then it's wraps that in an HTML tag, but it puts the little header tag in front of the body tag. Okay, so HTML is the house, and in the house there's two rooms. There's the header tag and the body tag, and inside the body tag room there's another room, and then the B tag is the closet. I guess. All right, and this, when I ran it, this is what it looked like. Okay. All right, now let's keep going.
Since an empty B/tag is not valid HTML, the parser turns it into a less than B/B tag pair. Here's the same document parsed as XML. Running this requires that you have LXML installed. Note that the empty B/tag is left alone, and that the document is given an XML declaration instead of being put into an HTML tag.
All right. Okay. Well, here's something interesting. Okay. So I don't really understand XML, and I'm guessing you don't either. And so let's see the changes. Okay. So instead of wrapping it in the HTML and the body tag, it just has this one little thing that says, hey, man, this is an XML version 1.0, and we're using the UTF/8 key for the character sets. Okay, and then it's just that. All right. Well, that's interesting. Both of us learned something today. Let's continue.
There are also differences between HTML parsers. If you give Beautiful Soup a perfectly formed HTML document, these differences won't matter. One parser will be faster than another, but they'll all give you a data structure that looks exactly like the original HTML document. But if the document is not perfectly formed, different parsers will give different results. Here's a short, invalid document parsed using LXML's HTML parser. Note that the dangling /p tag is simply ignored. Beautiful Soup.
Alrighty then. Okay, so it mentions something that needs to be talked about that people don't realize at first. Um, Even though like the two options look like they're creating the same output, some are faster at it than others. And that, when you're talking about milliseconds and it's just one, page, it's not a big deal. But when you're processing millions of pages at a time, that little bit of savings can add up to a big, big savings later on. And it makes a big difference when you're in a production environment. But you don't have to worry about that right now because you're just starting out. All right. So here we go. This is kind of interesting. This LXML didn't do the same as it did up here. Okay. It wrapped it in a body and an HTML tag, but there's no header. Isn't that interesting? Okay, let's keep going. And okay, now we're using the HTML5 lab. Okay. And what do we got here? We got the P tag buried inside of an A tag, buried inside the body tag, buried inside the HTML. And it's pretty much what we would expect it to be. All right, now let's keep going with our reading.
Instead of ignoring the dangling /p tag, HTML5lib pairs it with an opening p tag. This parser also adds an empty head tag to the document. Here's the same document parsed with Python's built-in HTML parser. Beautiful.
Okay. It's not the same. It's got all this other. Oh, I guess it is the same. HTML5, it gives us all this stuff. Now we're using the HTML-parser, and it doesn't give us anything. It just gives us the A tag. Whereas here, with this one, it fixed the problem by creating the P tag, and then it did all that wrapping within a body and HTML flags. That's interesting, at least I think it is. Anyway, let's finish up this last little bit of reading, and then we'll go off to the code and the output.
Like HTML5lib, this parser ignores the closing /p tag. Unlike HTML5lib, this parser makes no attempt to create a well-formed HTML document by adding a body tag. Unlike LXML, it doesn't even bother to add an HTML tag. Since the document A/P is invalid, none of these techniques is the correct way to handle it. The HTML5lib parser uses techniques that are part of the HTML5 standard, so it has the best claim on being the correct way, but all three techniques are legitimate. Differences between parsers can affect your script. If you're planning on distributing your script to other people, or running it on multiple machines, you should specify a parser in the Beautiful Soup constructor. That will reduce the chances that your users parse a document differently from the way you parse it.
Okay, so there you go. So I guess you're supposed to specify which parser to use if it's going to be running on multiple machines. All right, with that, let's run off and check out the... And here we are in the code, and thank God it's not a lot. You've seen it before. Bada boom, bada bing. If you need the code, just put in a comment and we'll figure out how to get it to you. All right, well, let's click the start button. Boom! And we have an output. But you can't see it. I can see it, but you can't see it. Oh, One last thing before we go. Notice I added, even though it's not in the manual, I added the prettify formatter equals minimal to my print statement on the soup object. Just want to point that out. Oh my, look how pretty this is. Well, I went ahead and I cut and pasted all this stuff in the document so we could compare and contrast it while we're doing our reading, but I'm just so happy that the outlook looks so much nicer now that we've learned how to use the prettify function correctly. And with that, this video is correct. I suggest you all go out and play, do something fun, perhaps throw rocks at each other, or do something dangerous with your bicycles. Try not to get too hurt, and we'll see you in the next video.